When you talk about access time of any database item, we don't need to think about only a stable storage organization or physical layout of the database storage. That is, taking care of physical storage like hard disk blocks, something like that. We have to think in another directions also, like how to organize, how to search, how to uh, group all this data so that we can reduce the total access time. So indexing is some kind of that, using which we can actually reduce our access time whenever we try to find any record in our database. So what we do in indexing, that we create and particular for the time being, just know that we have to create something for a particular database file, and we have to do because we want that to fetch data much quicker way. So what we do here, actually we take a set of attributes and we keep those attribute values in sorted order. These are keys. This can be used to locate any record. So what we are doing in the indexing, we select a set of attributes and we keep the values of that particular set of key attributes in a particular sorted order, maybe increasing or decreasing, whatever it is. And you are using those values to locate a particular record directly. So what we do here, we are creating another file called indexing, and we keep particular two records. We have two attributes in the file. What is the first attribute? Indicates the search key value, whatever we are selecting here, and the next entry will be the direct physical address to the particular record. Okay. The next question is, why should we go for indexing? So think about example that our database is a very bigger in size, very big in size. Okay, and we want to search a particular record, a set of record in the database. So what we have to do, that in a particular, if I consider this is our disks and these are our all sector, what you know that our database is divided into different blocks and they may be here, maybe here, maybe here, maybe here. So if I want to search, I have to start from the first block. Okay, if I consider this my different blocks of my database file, so I have to search from block 1, then block 2, then block 3, then block 4, then block 5, and we have to read all these blocks to our main memory, then we can search. So to search a particular record, we have to read whole block here, then we start searching whether it is in this particular block or not. If it is there, then we don't need to read the other blocks, but if it is not there, then we have to again read this block to be. Then we keep on doing unless we find the particular record in this block. So if we follow this whole process here, we are spending much time to reading blocks only, and then we are searching. So this is very time consuming, one thing. Another thing, that this disk access is a mechanical, and this searching is done on the RAM, so it is done on electronic devices. So this time lapse between this mechanical, that will be very high. So in the process of accessing any particular data, our aim or objective will be to reduce this access time. So if I create some environment like that, we have to deal with every block to search a particular record, that will be very time consuming, and if the number of block is in very high rate, then this time will be very high. So what we can do, that we select particular set of attributes in our database, suppose this id value, and we keep this id value to another file, we call it index file, and what we have here, just ID and the physical address of this ID. So we create all these values. Suppose 1, this is 100, this is 2, maybe 101, something like. We don't keep rest of the attribute value, only ID values and their corresponding physical address of particular records. So what you are achieving here, the index file is very less in size. Maybe whole index file can be fit in a single block. So whatever we have to do, we have to read just one block in the RAM, and we don't need to bother about physical block of all the records. What you are going to do, read the whole block and we search the particular ID if it is there. If it is not there, it is not a problem. If it is there, then we will obtain the physical address and we go direct to the particular block, maybe block 4 here. So we read this block and we get the record from here. We can also draw an analogy in real life also. Whenever we read any book, what do? We go to the end of the book. At the end of the book, we keep a certain set of keywords in a alphabetical order, and what we have there, along with keyword, we have page number also. So we go to the indexing, we also call indexing. We search the keyword here and we note the page address, page number. So directly go to the page number in the book, and whatever we want to do, read and write, whatever we want to do, we can do. So that is a similar thing we are doing here also. So we are just, in place of keywords, we are keeping the key attribute values. So that attribute value actually helps us to locate a particular record, because we are keeping address also along with this attribute value. So this is the different types of indexing we can have in our database system. So it is primarily categorized into order and hashed indexing. In order indexing, we have clustered and non-clustered, and under cluster we have dense and sparse. In the hashed indexing, we have static and dynamic. So in this particular lecture, we discuss about only order indexing. So in cluster indexing, what we do, we create index whose search key values and defines also the sequential order of the file. So search key values are creating the order of that file. Okay, and this file are sequential in nature. That is, every record follows the previous record. There will be no gap. And mainly we done on the basis of primary keys, but it is not like that. We have to do on primary keys. We can do on any search key value or any attribute value. So whenever we follow such kind of clustering indexing, and the file also follow that same order, we call that file index sequential file. So cluster indexing can be either dense or sparse. So what is happening in the dense structure? So you can see this example. This is the instructor table. First column, this is ID, then name, this department, and this is salary. Okay. And since it's a sequential file, every file contains the physical address of the next block. Okay. Now, it is our index file. What are we doing here? We are creating index entry for each ID value. Okay. So first ID goes here, and then we keep the physical address for first entry. So accordingly, we create all the entry for the index file based upon this ID value, and we are keeping all the ID values in the index file. So whenever we create index entry for all the values like this, we call it a dense order index. And the search key we are having here for every entry in the database also. So that's why we call it a order index. Okay. One problem with order index, that whenever the size of the database grows, this size of the index file also grows. So one solution is we can have sparse index. What we are doing here, we are keeping only few values for index entries. So for here we are keeping only this and then this and this. So the next question is that whenever we're trying to find a particular record, how we will approach. So what we have to do, suppose we have to find this particular record. So we know this ID of this record. So 15151. So what you have to do, I have to search this index file whose value is largest one but less than this value. So in this file, the here less than value and largest is this value. Okay, so you have to go this address. We start our searching from here. So this is not equal to my ID. This is not equal to my ID. Now when it comes here, I can find that this is equal to my search item. So I will get my particular record here. So what is the difference between the sparse and dense here? But you can see that whenever we try to find, suppose we try to find this data, we are directly getting this physical address, don't need to search it. But it has problem like its size grows when the database file size grows. But in this case, size is less, but we have to do something extra, that is we have to search this particular block. Okay, so this is the difference between dense and sparse structure. Now, even if we follow dense and sparse structure, there is a problem, because in real scenario or database not in small size, it grows according to time. So when your database becomes very large in size, what we have to do? So in that case, it is not possible to read whole entire index file into a RAM. It is not possible, because now index file become more than the available space. So we have to do something called second level indexing. So we have to create another level of indexing. We call it outer indexing, and your original indexing are divided into blocks. Okay, and in this outer indexing we keep the address of these inner indexing blocks. Okay, so whenever we try to search any record, we have to go here first, then you have to go here, then you have to collect physical address, and then from there we have to go to particular record, which is the actual record. So it happens when your database size gets bigger. So we have to deal with the index files also. So in this case, the outer indexing will be always dense in nature, and this indexing level, inner indexing, can be dense or sparse. So this is about multi-level indexing. So now what is secondary indexing? So whenever this comes under non-cluster. So whenever you try to create any indexing based upon some non-key value, so that will create another problem, because using non-key value we cannot actually locate any record uniquely. So for that we have what you have to do. Also in this case we cannot guarantee that our record is in sequential order. So what we have to do, we have to create another indirection level. Another indirection level. So what we are creating here, first we create a index file which is in this order, in ascending order, in sorted order. Okay, so you can see this is in sorted order, but our actual data is not in sorted order. So what we have to do, we have to create another indirection level. This indicates this physical address, but this physical address they are holding the actual physical address, that is actual address of the data. So this physical address in order index, this is in order, but this is not in order. So we are, suppose this we want to find this particular record, what you are getting here, and also we can see that we are creating index based upon salary data. So it is not guaranteed that salary data will not conflict to another record. So that's why you are sorting here, keeping all these physical second level intellectual addresses are in sequential order, but these addresses are actually holding addresses which are not in sequential order. So that's why you are creating a secondary level of indices, and we call this whole mechanism is secondary indices. Thank you.